Hello, everyone, and welcome to today's webinar, Getting Started with Post Quantum PKI. And this is a tech spotlight from both Thales TCT and us here at Keyfactor. My name is Mitch Marchand. I am a Senior Product Marketing Manager at Keyfactor, and I've got the distinct pleasure of riding alongside Gina Cinta. She is the Deputy CTO at Thales TCT, as well as Chris Hickman. He is a Chief Security Officer here at Keyfactor. And I'll give them just a second to introduce themselves once I get through a couple of housekeeping items. So just so you know, over on your right-hand side, you're going to have a little paper clip. That little paper clip is the attachment section, and you're going to see a number of different pieces of collateral around what we're going to be talking about here today, the tech spotlight, as well as how to future-proof your PKI, as well as if you want to book a demo. There's going to be a lot of great stuff talked about today. So if you want to learn more and actually see it, you'll be able to do that. As well as if you'd like to connect to Chris, Gina, or I on LinkedIn, we are constantly posting way too much around all the different happenings within the PKI world. So with that, I want to hand it over. So Gina, tell us a little bit about yourself as well as Thales TCT.
Okay, thank you for having me here today. My name is Gina Cinta. I'm the Deputy CTO at Thales Trusted Cyber Technologies. We are a small piece under a very big, large Thales umbrella. We focus on strictly U.S. federal government with our portfolio of products for encryption, identity access management, and data in motion and data at rest. We've been around for many, many years under many different other companies, but we are all US-based citizens, and we operate under a CFIUS agreement to where we have to stay separated from the parent because they are a foreign-owned company.
Awesome. Well, thank you, Gina. Chris, you and I have been at this for a little bit, so if you could tell the world a little bit about yourself as well as Keyfactor, please.
Certainly. Great to have Gina here today, and thank you very much for making the time first and foremost. And Keyfactor, I have the pleasure of being Chief Security Officer here at Keyfactor. Keyfactor is helping organizations in government and private industry get digital trust right by establishing good trust through our core PKI, which is our EJBCA. That we'll be talking about today, and then managing those certificates through our CLM platform, which we refer to as Command. And then just recently, we expanded the portfolio to include an acquisition we recently made of a company called InfoSec Global, which vastly expands our discovery, inventory, and monitoring and remediation capabilities, in particular in preparation for the topic we're going to be talking about today, this upcoming requirement to move to post-quantum cryptography.
Awesome. Well, thank you, Chris. And to the audience out there, you can definitely tell we've got some great minds here with us that are really going to help us understand this idea of post-quantum and really how it also affects particularly the federal space. So, Gina, I'm going to go ahead and start off with you. One of the things that we were talking about as we were prepping for this is there's a bunch of quantums out there. Quantum seems to be the word that goes before everything now. It's like the ultimate adjective. So what are some of those that are out there, and what are the ones that we're going to focus on today, and kind of why are we focusing on that one?
Right. Yeah, oftentimes when somebody brings up the word quantum, my next question is, which quantum are you talking about? Or when I bring up quantum, a lot of people say, oh, that's so complicated, I don't understand it. So it's good to understand what the different, when you're talking about quantum, what the different aspects of it are. The first one is the quantum computing aspect, which is, the capability to be able to, exploit properties of quantum mechanics to speed up computing, which is great. There'll be things you'll be able to, crunch numbers on or do, scientific research on and get an answer faster than you might normally receive it on classical computing. But then the downside of that is the threat that it creates because of its powerful capabilities. And we can get into that in a little bit. The other aspects of quantum is there's quantum key distribution, which is the use of quantum physics to do the distribution of keys. We're not talking about that today either. And then there's quantum random number generation, and that's really a hardware random number generator that's used to generate a random non-deterministic randomness. There's an aspect of our hardware security modules that leverages that. We can talk about that later. But really why we're here today is to talk about post-quantum cryptography and to be able to have your cryptographic systems that are secure against that quantum, threat where they'll be able to break, PKI, which is this, number one subject we're here today to talk about, the PKI encryption that we've known for years, and the ability to now support new algorithms that came out from NIST last year, to be able to be more quantum safe. But the migration effort is going to be, quite an arduous task. But it's good to understand the different quantums. One time, someone from IBM was doing a presentation. He talked about like the yin and yang of quantum, where he really talked about quantum computing is the yin and the yang is the post-quantum cryptography. So we're going to talk all about the yang today. So that's another way of keeping it simple and understanding which quantum are we talking about.
Yeah, every time I jump on with a new partner, I hear a new application or a new term. So thank you for kind of lining that out. And
Yep.
one of the things that we were talking about that goes along with this concept is, can you tell me a little bit about the NCCOE?
Yes. So the National Cybersecurity Center of Excellence is a part of NIST. It's located in Rockville, Maryland, and they started a migration to post-quantum cryptography project a couple of years ago, where we were one of the first 12 or 14 collaborators. There's now almost 50 collaborators that are involved in this migration effort. There's two work streams. There's the discovery work stream, which is kind of like where InfoSec Global falls, where they can do discovery of the crypto that enables you to then, know where it is that you need to migrate the algorithms. And then there's the interoperability and performance work stream, where we, Thales TCT, are playing right now, in where we're testing we originally tested the pre-standard algorithms with our HSMs and other HSM vendors that are part of the collaboration. And then there's reports that get produced from the NCCOE on their website that are really good, valuable reference materials that will help you in your migration effort. So I really encourage you to take a look at the NCCOE website, and all you have to do is type in NCCOE post-migration crypto, whatever, you'll get it right away. It is, probably the largest project going on there now. I think Zero Trust was the larger one before that. But it's definitely global participation. Just because NCCOE is under NIST and that's a US government agency, this is a global challenge, and the collaborators are participating in this from across the globe to help ease the pain of this migration effort.
And I think, Gina, that's a really interesting call out, right? Is that the world is trusting NIST here to
Yeah.
make the decisions when the problem was identified. They very quickly realized there isn't time for everybody to take their or have their take on this, because the threat landscape is so big.
Yep.
And NIST really has taken ownership and a substantial leadership that the world is now depending on groups like this to be able to follow through on
Yep.
where they've standardized and turn that into practical
Yeah.
applications and the such. So,
And
hats
they've been
off.
really good about briefing the collaborators on different aspects of like where the standards were at through the standardization process, and introducing, like the crypto agility, which you're going to talk about in a little bit, where they're getting involved in that too. So they really look to this group for guidance, and it's I always like to say it's a safe space, because a lot of the collaborators are competitors and in the sales space, right? But we really are working together to collaborate to solve a problem, which I think is just really a neat aspect of this organization, and how they bring everybody together to solve a very hard, challenging problem.
Yeah, absolutely. And so hitting on that piece of it being a hard problem. So Chris, why is this so important to the federal space that we're pulling this conversation together even?
Well, so if we think about the threat that a quantum computer poses at some point in time in the future to classical cryptography. So here we're referring to things that PKI are based on, specifically RSA and ECC, but any asymmetric type of encryption is potentially within the scope of being broken by a quantum computer. And it's important because of a number of different things. First and foremost, nobody wants their encryption broken. Let's just stay with that. And obviously, from a federal government perspective, it's important to realize that there is very sensitive information at play. We don't know who is going to actually break encryption first. So there is a possibility that it could be through academia or through commercial means, or it could be state-sponsored type of activities. And so, we have to assume just the if you will, the lowest common denominator, which is data is going to fall into the hands of somebody you probably don't want to have reading it, right? And this is starting to happen today with Harvest Now Decrypt Later or Steal Now Decrypt Later, where systems are being infiltrated, encrypted data is being stolen, and for the purposes of decrypting it later. And if you think about it, different data has different lifetimes, but things like let's say military assets or personnel records or any number of things that one would deem sort of intellectual property within government has a high degree of sensitivity and a long lifespan. So, to that end, there were a series of executive orders that were placed originally under the Biden administration, but recently updated by the Trump administration for organizations within federal government to start tackling this problem. And it laid out some timelines, and some of the amendments changed the timelines slightly, but really didn't take away from the nature of what the intent is, which is to do what you need to do to get ready to migrate to post quantum, and to do that in a way that takes your most valuable assets first, and then moves on to your next line of classified data, so on and so forth, because you can't boil the ocean. It's got to be done in a systematic way. It's also worth calling out that it's a very codependent ecosystem of cryptography, right? We're not just talking about changing one credential for another. We're actually talking about changing the entire cryptographic ecosystem from one set of standards to another, and it's never been done before. And if we think about it in those terms, as Gina was saying, it's a tremendous uplift for organizations to go through. Very, I will say, risk prone if not properly addressed. And with a criticality behind it to continue to keep the data safe. So it's kind of the perfect storm, if you will. And just to sort of talk through, when does that have to happen by? I think the current guidance from NIST says 2030 is the preferred timeline. 2035 is a hard stop. Different guidance there that I recommend everybody take the time to look at as to when the current algorithms will be deprecated. But also, there's some emerging things around crypto agility and how that plays into it. So crypto agility is basically the ability to be agile with cryptography. And NIST has recently come out with a working group that has been focused on better defining crypto agility. So taking it from if you will, a marketing term to a real technology integration place, and practical advice around that, and really starting to build this. Because at the end of the day, there is no day that we can look to. It's not like Y2K where we could say things are going to happen on this day. So we really have to take this idea of, it's not a quantum day or a Q day. It's I call it the quantum vortex. There's just all this stuff swirling around, and we don't know exactly where the center point is because we don't have a day. So we have to assume that the day was actually yesterday is only really the right strategy to take, because we don't know what that day is going to be, and we don't know the progress of foreign actors who may not be sharing their updates like academia are and commercial industries are.
Awesome. Well, one of the things you mentioned there, we're talking about standards and we're talking about timelines. So, Gina, I know you've been involved with quite a bit of this. Could you talk a little bit about the CNSA 2.0 timeline?
Yeah. So NSA came out with the CNSA 2.0 timeline, identifying different aspects of where you need to be with certain components over time. And some of those are like software firmware signing. when you need to start adding that option, having it tested, when it needs to be ready. Web browsers and servers, that's the other thing you have to think about. Like, this affects web browsers and servers. It affects the transport layer, like TLS and SSH. It's not just, excuse me, it's not just your data that you have, sitting in your databases and your file servers and things like that. It affects operating systems, and things like your smart cards. Like, you have to think about, now I'm going to have a, PQC enabled, PIV card. And so there's so many aspects to this other than just, your data and that, harvest now, decrypt later. It's all the things from end to end and in between. So it really affects everybody in the organization, and the CNSA 2.0 timeline is really a great tool to look at, just to kind of leverage that to use in your planning process. And, a couple of years ago when I started talking about quantum and PQC, it was more like, get ready, get ready. Now it's like, you need to be doing it. You need to, have a plan in place, and you need to start executing on that plan. And, the CNSA 2.0 timeline is a great reference material for you. And I've seen, although it came out of NSA, I have seen some commercial organizations starting to recommend it as well. So I don't think whatever's happening, and it's kind of unusual that the government's leading the way on this, because oftentimes they tend to be the follower with new technologies or new threats or something like that. But this is something where, like, you've got CISA, you've got NSA, and you've got NIST all working together to give you guidance, along with the White House, where to go and how to start getting your arms wrapped around this. And, one of the things is, like, your high priority systems, your high risk systems should be the first things you tackle when, you're going in to discover, where's that crypto and how am I going to protect it? Because those are at the greatest risk, because you're not going to be able to do everything at the same time. And you're going to have a plan come together to figure out, how are we going to tackle this very arduous task.
Yeah, and the plan is a perfect segue, almost like we planned it, into talking about our readiness roadmap. So again, this is Thales branded, so it came from Thales. And the cool part about the relationship that we have between Thales and Keyfactor is we're focused on the same problem, but we're coming at it from different directions. So I'll kind of ask both of you to go over this a little bit. And Gina, since it is your slide, I'll let you kind of take the first crack at discussing the roadmap that you just were.
Yep, and this has kind of been evolving too, right? Like, the way we had it laid out a year ago or 2 years ago has changed, just based on different, things that are happening and as people are starting to progress. So, really, first of all, it's important to designate a leader to spearhead that effort. A good example of that was last year, CISA came out with guidelines for submitting your crypto inventory. And they gave you a deadline of civilian agencies needed to submit their inventory to CISA, where CISA created a spreadsheet and said, here's this spreadsheet, fill out your crypto inventory, get it back to us by, I think it was May of last year. A lot of agencies didn't meet that deadline because it's a challenge. Well, they designated somebody within CISA to spearhead that effort, right? I actually talked to him one time. I was like, you didn't ask for this job, did you? And he goes, no. And, he was looking to take this information and a spreadsheet and putting it into a database, but now you've got, like, now the next priority is to automate that crypto discovery, right? Because whatever they put in that spreadsheet last year is probably old news, right? Because they've created more crypto since then. And that's the beauty of these crypto discovery tools, is it's something you can set into place, and it can do the discovery of the crypto on a repetitive basis. So you can keep it's more a living document than a one and done kind of thing. And that's where, your acquisition of InfoSec Global comes into play, because they're one of those players in that discovery space, right? Then now that you've done this crypto inventory, the next step is developing a transition plan, right? And setting up a PQC test environment. And that falls right into, I think, our next topic, where we talk about, why we're doing this partnership and, how we can enable you to do this. Now, we created, we had like the pre-standard algorithms available in our e-lab for our technology partners to test with for like 2 years now. And then at some point we made them available as a firmware upgrade for our users, to our customers, so if they wanted to do it in a test environment, to do that. But now we're, finalizing the algorithms in the HSMs to support the standards that came out last year. And we've come together with Keyfactor to put together this really cool capability of a starter kit to bring these two solutions together to kind of help you get started.
Yeah, Chris, if I could have you take it home with some of the last steps here, and then we'll talk about the kit.
Yeah, so just to go back to the testing piece as well, I think it's really important to call out that post quantum keys are not the same as RSA keys. It's not like traditionally where we've just said make the key length bigger, make it bigger, make it bigger. It's a completely different type of key. It's a different type of math. They are very large compared to your traditional RSA, and in particular your traditional ECC keys. So they don't necessarily migrate particularly easy, and that's why testing is such an important element. People need to learn about them, figure out what's going to be successfully migrated, what might need to be replaced, or changes need to be made to infrastructure, so on and so forth. In some cases, that test part is really, really critical to be set up with the right skills and information to move forward, along this timeline, if you will. And the crypto agility piece too is a build once but use many times. If people people will very quickly realize that cryptography has been grossly undermanaged within organizations, and traditionally it's sort of been a checkbox on an RFP, right? Do you support this? Yes. Do you support this? Yes. And then those documents get filed for 7 years, eventually shredded, and that's how we've managed crypto, believe it or not. But that's exactly where we're at. So the whole intention of building to this plan is not only to get ready for this one event, but to continuously be able to adapt, because we also don't know what the next series of threats look like. We don't, while we have confidence in the algorithms that have been released, a vulnerability or might be exposed to them at some point in time in the future, and you want to continue to be agile. And just even outside of the post-quantum piece, you're going to be rotating your TLS certs every 47 days. Those that are publicly rooted, right? Here coming up in scaling into 2029. That whole motion of agility plays across multiple use cases. And then moving forward, one of the reasons we partnered with Thales TCT here is because they have built out the HSM ready for quantum that takes all the quantum use cases, specifically for PKI, because that's sort of our focus, but not exclusively only for PKI, into account. So if everybody by this time next year is at a point where they've done their testing, they have their inventory and discovery, and have a plan for crypto agility, they'll probably be in a decent spot to be able to tackle the actual migration piece of it. And then it's really implementing, right? Then it's unlocking the budget and doing the things that you need to do, and moving forward from what you've learned in test and moving that at scale into production. So once we are successful here, at this stage, it's really going to set the stage for moving forward. But I think it is important too to come back to this notion of it is a change in cryptography, not just a change in a certificate. As was mentioned, TLS 1.3 is a precursor for running post quantum. Applications have crypto embedded in them all over the place. Routers, websites you mentioned, mobile phones. Every single mobile phone is going to have to adopt a post-quantum algorithm, so on and so forth. So it is really a large landscape, but does require these steps to preparation.
Right. Well, and like NIST came out with 3 of the algorithms last year they standardized on, right? MLChem, MLDSA, SLHDSA. But there's still 2 more that they're hoping to standardize on by well, Falcon was supposed to be done by the end of last year, but that didn't happen.
Yeah.
They indicated the math was quite complicated, so it's going to take them longer than that. But they think it's going to be sometime this year, I think, from what I've heard.
Yeah.
And then HQC was something they came out with earlier I think it was the spring of this year, and they're hoping to finalize that standard by 2027. And there's a whole nother list of like 10 or 14 or something like that.
Yeah, last I saw there was 16 in the on-ramp program,
yeah,
16 new algorithms. So
that they're now examining in other sets, because what happens if one of these ones they first came out with does get broken? You've got to be able to change it to support something that's going to be able to be stronger than what the standard might have originally come out with. So they're not done. They've got a long way to go, and this has been years in the making, them getting to this point where these standards a lot of them were contributed by industry and academia and government globally, and down selected through like a competition process, to where they've picked the ones they think are going to be the most effective, and so they've taken their time. And we as an industry have to make sure that we are able to continue to support anything that comes along as well. So we've got to stay in lockstep with the standards that are coming as well.
And I think most people, if you haven't worked in this space maybe as much as you and I have, Gina, people don't realize this has been an effort that started in 2016 to get the standardization for these first three algorithms. So, I think it'll move a lot more quickly for the next batch. But it's been a long-term effort to get here, and it's not a problem that's only being thought of today and recommendations made in haste. It's been a long time coming.
Yeah. Yep.
Awesome. Well, the biggest thing that I continue to hear, I've heard you guys talk about it multiple times, is testing. Because again, this has never been done. We've seen what happened with SHA 1 to SHA 2 and all the other examples, and this is much larger than that. So really, and kind of the biggest reason that we're all here today is to talk about the next step and what we can basically do as our combined efforts to help ease this process along. So, Chris, without further ado, if I could have you talk a little bit about the PQC starter kit.
Absolutely. So the PQC starter kit is a combined effort between Thales TCT. I don't know why I stumble on that one, and Keyfactor, to essentially give if you will, an out-of-the-box experience for organizations to be able to plug and play these two technologies and have them just go and work. It's available today. So this is not something we have coming. This is something that you can order today, and this really is the foundation of post-quantum cryptography for your organization. These are two things that you're going to have in order to be able to issue post-quantum certs and other versions that come up, because just like Gina mentioned, as things come up, we will continue to incorporate them and new standards into the EJBCA platform. Really, this is we've had a very long history between the two organizations, and when we looked at what our customers were going to need, both within the government space and in enterprise as well, we mutually decided as organizations that we wanted to do the work to make sure that this was an easy place for customers to start, and that they didn't have to go through the efforts of trying to figure out integration between two sort of commercial off-the-shelf solutions, and that we can package them in a way that was more favorable, easy to use, and they don't have to sort of be what I call patient zero of PQC, trying to figure it out for themselves. So we've done all the testing with Thales, and Thales has done the testing against our stacks. And we have the integration layers that are required for the organization to be successful right out of the gate. I'll add to that as well that along with this, there is access. We include access to Keyfactor University, which is where you can learn a lot about post-quantum just in general, but also learn about some of the integration points that you can leverage with these sort of outside this solution. But obviously, this solution doesn't solve a problem unless you've got applications or devices that are also consuming those, which will eventually have to be a part of your testing.
Well, and they might say, I already have an HSM in my, non-prod environment that I could use for testing. It's already set up with Keyfactor. But do you really want to mess with that environment when you have to continue to support that and anything that's going on production in the meantime? So this is a good way to be able to, set up a separate testing environment for specific to PQC, where you're not going to be walking on top of something you might have in non-prod already. And we know you definitely don't want to do this in production yet. So this is a good way to start setting up a separate little environment, within your non-production testing environment that's specific to PQC. And that's exactly what's been happening at NCCOE too, right? There's a lab there where we installed our HSMs and made it available, for people to use and test with during, that project that's specific to PQC. And we keep that HSM up to date, supporting what's happening with PQC, right? It's not being used in the lab for anything but the PQC project.
And there's a high likelihood, to your point about production versus test. So your production environment doesn't have a lot of post quantum enabled things on it. So it would limit your ability to be able to go through that testing. And as your vendors, across, like I said, your entire ecosystem, be it the HPs, the Palo Altos of the world, be it your software vendors, the Microsofts or the Linux, and so on and so forth, as they introduce their post quantum enabled products, this will give you an opportunity to bring them into that test environment, make sure that they do actually function the way you expect them to with this new type of cryptography. So it becomes very, very critical to be able to test those to make sure you have that confidence moving into production as well.
Yeah, that's a ton of great points. I'm very excited as soon as I got brought in on this project to okay, this thing's going to basically sell itself. And I think it's a great concept. So just in a few sentences, Chris, if you could explain what's the difference between EJBCA and why is it the secret sauce from the PKI side? And then Gina, I'll come over to you to talk about what's the difference between the Thales Luna and the rest of the world.
Okay.
So EJBCA is a product that we've at Keyfactor had a relationship with that team prior to them joining the Keyfactor family. It is a enterprise class CA. It's highly scalable, available in a couple of different form factors. But the point being is that it's highly scalable, very easy to deploy, very easy to manage, and allows organizations to do PKI in the way that honestly PKI should be done. I've been in the PKI space for over 30 years now. It supports your standard protocols around ACME and SCEP and these types of integrations. But where it really excels in the post-quantum world is we've had the post-quantum capability built into EJBCA since almost day one. Initially with Thales, when the candidates were out, we built to the candidates and tested them and figured out, okay, these things are much bigger and they operate differently and there's performance impacts you have to take into account and to optimize your software accordingly. And so we had a lot of knowledge from that for the day in which the protocols were actually the algorithms, were actually finalized and announced by NIST to be able to do that transition over. Everything in the Keyfactor family is post-quantum enabled, be it our EJBCA or our command or our signing platform, so on and so forth. We've really led with, let's get the quantum algorithms there. Let's make sure that they work correctly, so that we don't, let's, for instance, CA become an obstacle to organizations starting this process of getting ready for this transition. So to me, it's really been about setting up our customers for success as early as we can, because we know that the time is coming a lot faster than I think anybody would like it to be coming, and therefore they shouldn't have to be waiting behind our roadmap.
Yeah, exactly. And Gina, from your side, how does Thales fit into this?
Yeah, so kind of the same perspective as, we started building quantum into our latest Luna T-Series HSM when we were developing the platform several years ago. One of the examples of that is right on the HSM card, we have a QRNG chip on the board. So you can actually get quantum entropy as a source from the HSM board, and you don't have to get it from an external source. It's a ID Quantique chip that we worked with that company to put that chip on the board. It's a minor feature activation capability. So any customer that has a Luna T-Series HSM today has that QRNG chip already on the board, and it's a matter of activating that feature to be able to leverage that capability. We did the pre-standard algorithms. We implemented those on the HSM. We're in the final stages of putting the final touches on the algorithms to meet the standard. So there are some tweaks involved, and we're doing additional testing to make sure they're very stable. Before we release those to be used in the HSM, but it's very closely forthcoming. We've also been sure to secure the communications to the HSMs using PQC enabled protocols as well. Some of that, we're reliant on, those protocols to be ready, like TLS and things like that. So sometimes we're dependent on something else in order to be able to achieve it. But from within the HSM ourselves, we've been working to make sure that everything is quantum safe. We've also got a quantum safe firmware updates that we can, do to the HSM, where you can do both an RSA and PQC root of trust, so that you can maintain that FIPS 140 compliance. The other neat thing about the HSM is it contains partitions where you can store key material. So you may have the partition that's working with, Keyfactor's EJBCA client interface. But then if there's other integrations with the HSM that you also want to test, that'll give you that value add of being able to test other integrations on the HSM as well by leveraging a different partition on the HSM for those separate high value asset keys. So there's a lot of capabilities there that have been built into the HSM, not only to support one integration, but multiple integrations as well.
Yeah, I love that idea. And as Chris mentioned, we've got a full stack, so we can definitely plug in talking about sign server here. So not only do we have to have a PKI, but as you mentioned on previous slides as well, we have to have firmware and code signing. That's also going to be another piece. So being able to have those multiple partitions is actually quite huge. So we've got a few minutes left here. I kind of want to go through a little bit more of almost like a Q&A. We haven't had any come in from the audience just yet, but some other things that we had talked about as we were prepping for this is we talk about deployment options. Obviously, we're giving a piece of software and a physical hardware for this kit, but does Thales offer different types of deployment options? And then I'll follow up, Chris, with you.
Yeah, so we not only have the hardware appliances, but we also have HSM as a service that's available to our customers. It's in a FedRAMP High authorized cloud through our partner called XTech in their Authentix cloud. So if a customer wants to do it, you leverage the HSM as a service as their testing ground rather than the appliance. That's also an option that they could do as well.
Yeah, Chris, how does Keyfactor play with the cloud?
Well, from the EJBCA perspective, it's available in either traditional software or a container. So we have multiple different delivery options there. For the crypto agility for the certificates, which is not part of this starter kit, but something that organizations will probably want to look at. How do they orchestrate the deployment of certificates and automate that so they're not sort of running around with USB sticks trying to do this manually? That is a solution that is available in FedRAMP today as our CLA as a service is there and available. So organizations certainly can leverage all of this in a multitude of different manners.
Yeah, absolutely. One of the other things I really like, and it's been touched on, is the relationship between the two companies. Chris, you said you've been in the industry for 30 plus years. How do you see the relationship, and how has it developed over the years that you've been even at Keyfactor?
Great question, because I think relationships are really where good business starts. You know, I've had the pleasure of working with various Thales teams, you know, over the course of my career. And when I came to Keyfactor, very honestly, I wanted to bring that into our Keyfactor culture, because I'd had so much success with Thales in my career. You know, they just make great product that works, and sometimes that's the most important thing, right? Secondly, they stand behind it. If you need something, if it for some reason doesn't work, which usually is human error, not product problem, yeah, they're there to help you and stand behind you. And it's a, you know, as Gina said, it's a sizable organization with many with lots of resources. And while you know, Thales TCT is a subsidiary, you know, standalone business unit, they still have the support of larger organization.
Yes.
And the intelligence, if you will, of the larger organization to help. So nothing. I've never come to Thales with a problem or a statement of a use case that hasn't been resolvable somewhere. And I have a lot of respect for that. So yeah, we've got a solid relationship, both commercially but also a lot vested in each other's interest to be successful in this space. And as I said, you know, at the end of the day, it just comes down to working with a great organization with great technology, but also great people standing behind it.
Yeah, like, I mean, although our HSM, it was, you know, built for U.S. federal government. It is CNSS approved, which is another thing that is unique to our HSM that other HSMs on the market are not. But it's a long history of that name Luna tied to the HSM. It goes back to when I first started with the company called SafeNet. And, you know, through several acquisitions is now a part of the Thales portfolio. And frankly, one of the reasons why they wanted to, you know, they wanted us was for that HSM and that history of, you know, quality product. You know, sometimes because, like you said, they just work, you know, and you have to end of life something for new technology. Customers like, but it's still working. And that's one of the things you need to understand with PQC is that we're developing all this PQC enabled quantum safe capabilities within the HSM that is, you know, today, not from an HSM that we end of life, you know, years ago, right? So even though a customer may be running an old HSM that's no longer supported, they're not going to get that PQC enabled capability. They're going to need to upgrade, which from the federal space, most of those, you know, those customers have done that. And really, you know, the value of the HSM is in our technology partner ecosystem, because by itself, it stores keys. But, you know, without the integrations with our technology partners, it's really, I used to always say it's like a boat anchor, but it's really just a black box, right? It has no, you know, its capability is not standalone. Its capability is in the value it brings to our technology partners that give you a place to store your high value asset keys in a FIPS, you know, certified appliance that is, you know, tried and true tested. And that's, you know, something that, and that's why our technology partner ecosystem is as big as it is. We have hundreds of integrations with the HSM. And that's where, you know, you see the value in purchasing an HSM is that you can use it for more than one use case. And you see that value, you know, from that time over time. But number one use case for the HSM is PKI. That is the number one use case.
Yeah, and I hate to cut off good conversation. I know we had talked a little bit about doing some other questions, but time is always short whenever we're having good conversation. And now the slides are not wanting to come up, of course. But basically, if it does come up, what you'll see is I kind of boil things down to 3 points. And that's always what I try to make it. So let's see if I can try this in a different direction. Oh, there they go, of course. All right. There we go. 3 key takeaways in the last 30 seconds here. Number one, the PQC regulations are, for the longest time, we've had the word coming. I was told we need to put a strike through that because they are here. And the time to start preparing was yesterday. So the next best day to start preparing is today, which is why we're offering the the kit that we are. And I think that's going to be one of the biggest things. So again, over on the right-hand side, you're going to have the ability to see what that kit looks like in a more detailed manner. And just like Gina and Chris were both going with, was this partnership has the experience, the knowledge, and the resources to move you towards PQC readiness and crypto agility. And I think that that's going to continue into the future. So I know we are right at time. So Gina, Chris, thank you so much for joining. This was a great conversation as always. Thank you to everyone who's attending today. And if you have any questions, please feel free to reach out to any of us. Thank you all.
Thank you.